My name's Kate Evans, and my title is Division Director of the Computational Sciences and Engineering Division. I've been a SCIEM member for a long time. It actually is a great home for computational scientists like climate scientists.
My name is Juan Restrepo. I'm a section head in the mathematics and computation. My area of expertise is the intersection between data and dynamics. And it's very, very impactful science, particularly in areas of climate and resilience.
I'm Slaven Peles. I'm computational scientist at Oak Ridge National Laboratory. SCIEM, which stands for Society for Industrial and Applied Mathematics, has a very important role to fill. Fundamental mathematics research is very important. On my current project, my team and I are trying to use supercomputers to ensure that we can keep the lights on without scorching our planet. We have extreme droughts and wildfires going on as we speak now in New Mexico and California. For the last 6 years in a row, I believe, we had above normal hurricane season in the Gulf of Mexico. So all of these things are caused by the climate change. And unless we change, we are going to be in trouble.
Climate modeling is a collection of all different forms of science all in one model. So we have atmospheric models, which tell you what's happening all over the globe at any given time and up to 50, 100 years in the future. We have ocean models, which are similar to atmosphere, but not as for reasons you can imagine, right? It's a solid water rather than air, but also a big global model. We have ice sheet models, land surface models, plants models, biology models. You need to capture everything from plankton eating bacteria all the way up to the largest waves in the high atmosphere. All the different things that are happening in the globe at one time all go together and run at the same time on these supercomputers.
The climate, as well as in biology, are systems that are very noisy and forced. And so the big challenge there is that they are very unstable statistically. Making predictions in those conditions is both a technical challenge, but also a philosophical challenge. What does it mean to make a prediction when something is changing over time?
We don't know how many people are going to drive to work tomorrow, so we can't tell you exactly how much carbon is going to go into the atmosphere. We have to incorporate all that uncertainty into our models to tell you what will happen in the future.
We're putting into these computations things that we don't quite understand, but we need them in the mix. And those can be captured using machine learning techniques. We are working on making predictions across scales in climate. We don't know how the small scale and the large scale interact. We need them to make our predictions better. We can actually make more nuanced and better decisions, more sensible decisions that don't require some optimality.
I take those algorithms and then implement them in our climate models so that those algorithms are used on the supercomputers.
We require lots and lots of climate simulations. We need them very, very quickly. We need them on the spot, essentially, and we need as many as we can. We will actually be using these simulations to force, for example, an electric grid or some system that Slaven is actually able to completely, fully simulate and capture.
We unfortunately don't have several centuries to practice. So what we need to do is we need to explore and learn by running extensive computations and simulations. So we are creating virtual world with virtual grids, and we are trying all possible scenarios that we can think of.
We've solved many big science challenges in our day. We solved the ozone hole, right? We uncovered the fact that the ozone was being depleted over the stratosphere of the southern hemisphere, and we brought all the great science minds together in atmosphere and climatology, and we uncovered the issue and solved the problem. Our field did this work when we uncovered it, and I firmly believe we have those solutions for climate change.
I'm a scientist. Climate change is one of the most pressing science problems of all time. So once I got the opportunity to work on at least a small part of the solution to that problem, I didn't think twice. Let me just finish with a quote. A society grows great when old men plant trees whose shade they know they shall never sit in.